Hi guys, how are you all?
I'm good.
Hi Ritik, what are you doing in school?
We are doing sinusoidal applications.
Sinusoidal applications. How is it for you? Is it easy, hard?
It's some of them are easy. Yeah.
Yeah, sinusoidal applications are definitely easy. See, once you understand the transformation, right, the topic is pretty easy. What are you doing, Naisha?
Um, I wasn't here last class, so I'm checking on the calendar right now. What?
No, you remember, right? Based on that, what are you doing? I asked.
Well, we did the. We're gonna start unit circles next class. I know that. And then,
You're going to
current.
start unit circles?
Yes, we're gonna start unit circles.
Oh, they are really slow, right? Okay, I see.
Yeah,
Okay.
and then we're just doing the like periodic functions and stuff.
Okay, easy?
Yeah, they're easy.
Yep. Nidhi, how about you, ma?
Next class we're doing unit circles and we did right triangle trigonometry and radians and degrees. That's it.
Oh, then it's pretty easy for you, right?
Yeah, it is.
Okay. Then, okay. See, what I don't understand is why such a vast difference. Ahana, for you?
We're also doing unit circles. Nisha and I are in the same school.
Oh, okay. Then, are you finding it easy at school?
Yeah, like it's just been introduced, but yeah, it's pretty simple.
I see. And are you using what we are learning here?
Yeah,
But we are way ahead here, right?
yeah.
Oh, I see. Interesting. Okay. See, but with this pace itself, I'm worried whether we'll finish or not for AP exam. You see what I mean? Huh? It's a lot of content, not hard content though. Interesting. Anyway, okay, let's move on. One second, guys. Applications as well. I have today I want to cover application transformations and 1 minute. Somebody's coming in. 1 second, guys. Maybe Biba. Okay, I want to share my notes with you. Okay, let's go over some transformations and applications first. Okay. So I am thinking of covering a lot, but I don't know how much of it we'll cover. Bhuvnesh, for you, is there any upcoming test?
I don't know. I have to check because the schedule got changed.
Oh, okay. Okay. I would like you to check for sure.
Okay.
Okay. So last week we went over 3.89. We were just beginning with tangent functions, remember? So I would like to see where we are on that. I know I have completed transformations of sine and cosine.
Miss
What is
Priya,
it?
can we review the phase shift and the period part?
Absolutely, absolutely. See that's what I wanted to first do. While I'm not going to do the sine cos, let's see. Meaning I'll review one or two graphs and then tangent. Okay. See, there is some data modeling as well. Data modeling we'll do later, but let's see whether you remember a bit of the transformations of sine and cos. That is quite important. Okay. We'll start with an easy function to review, and then we'll go ahead with a hard one. Let's see. One by one we'll do. Okay. How about okay. How about this? You all remember the general format is what I'm thinking. So I'm going to go over transformations of sinusoidal functions, starting with sine and cos. Sine and cos I've already covered, I clearly know, but then I'm just going to review what we learned. Okay, so 3 cos x plus pi by 2, 3 cos x plus pi by 2. Ritik, have they covered the transformations of sine and cos?
Yeah, they covered all functions.
Nice, plus 2. So let's go ahead. Oh, and we need to draw the graphs for secant, cosecant, and cotan today. Not a hard one at all. Okay, once you understood these three, it's very easy. So can we go ahead and plot this, guys? You want me to plot? Let me know as well. Or you want to do by yourself? I'm open. You want me to do?
Can we try?
Oh, you want to try? Okay, go ahead. See, but one thing is, I really want you to write out amplitude, midline, min value, max value, period, phase shift. All these details I want you to write down before you draw. You want me to write down what I want? What not? Just want a nice graph for me to draw as well. So let me use this graph for me to draw for you. I'll be using this graph. So what and all, meaning if you are understanding what these stand for, then it should be very easy for you. Amplitude, midline, what else? Min, max, period, phase shift. If you are able to write all of this from the equation, then it's very easy. Can we try? Oh, wow, that was fast. Okay, Vibha, noted, Vibha. Oh, wow, nice, Vibha. Period is one now. That is a little crazy for me. Period cannot be one, right? Period
Oh,
should.
wait, Auntie, I completely messed it up. I was thinking like the wrong thing. Wait, let me fix my previous answer.
No worries, take your time. So amplitude, you want me to go ahead and do? I will go ahead and do. Bhuvanesh, can you tell me what is the amplitude?
3,
3. What is the midline?
2,
How do you know? Yeah. Midline is y equal to 2. It's an equation, right? So y equal to 2 is the midline, means first I will draw this, and the next one, minimum is what? Minimum is, see, midline is 2. Amplitude is 3. So plus 3 and minus 3, right? So minimum is
Minus
what?
1, negative
Yeah.
1, and
Minus
5.
max is, yes, 5. Period is, yeah, period is usually for a parent graph, it's 2 pi, right?
Yeah,
So this one,
2 pi.
yeah, y, b is what?
B,
B is 1 here,
is 1.
right?
Yeah,
So 2 pi, phase shift is
negative
5 pi over 2,
pi by 2 to the left or right?
left.
Yeah, that's it. So now you should be able to draw, I feel, right? So basically my sine graph means 3, amplitude is, max is 5. This is sine graph, right? Okay, so this should be 0, 0. Pi by 2 should be 5, right? 2, 3, 4, 5. Yeah, I'll draw the original graph. I always apply the phase shift later, okay? That way I don't get confused. You see what I mean? If I were you, I would do that, but I'll leave it to you. So here it is a minus 1, should go till here. And then in 2 pi, it should come back, right? To 0. But what happens here? I accounted for amplitude, midline. I would like each of you to show me the graph, please. Min, max, period I accounted for, phase shift I didn't account for. So it is pi by 2 to the left, means this point moves here. This point moves here. This point moves here. Right? This point moves here. Then this point moves pi by 2. Pi by 2 is 2 columns. So see here, it goes like this. Thanks. Clear? Any questions? Okay, next one I would like each of you to show me. Ritik, did you get the graph?
Yeah, I got the graph.
See, when you go out of the class, you should be able to plot sine, cos, tan, secant, cosecant, cotangent. Okay, can I move on? I'll give you one. I'm not going to rush. Okay, we'll do one more from your end and then I'll go. How about this? Minus 2 sine. Let me see. I would like you to plot for this. Minus 2 sine 2x minus pi minus 1. Can we try? Let's try, guys. Try. Please, I would like to see your graphs this time, if you don't mind. Nice.
These pieces are for like organizing it into this so that we can demonstrate how they get together. And then I have 4 things inside.
But I'm going to take pictures with a big tub of water.
I know.
Dump
About
this.
that, yeah. And then we're gonna put this into there.
We can fill the tub with water.
Yes. How do
Oh, very nice, Bhuvanesh, to see your answer. But did you not miss something, Bhuvanesh?
I think check again.
No, you did everything, okay, which I'm happy about. 1 minute, huh? Bye. 1 minute, huh? Yeah, Bhuvanesh, everything is okay. But did you account for the minus in front?
I counted as a reflection.
Yeah, but that's not in here, right?
Although
You see, in the list of things that you have written, right? It's not in there. But maybe, see, you accounted for it. I'm fine. But you did not write it down. That's all.
yeah.
Ritik, we don't write vertical reflection, right? What does it mean? Vertical reflection means at least explain to me what it is.
Okay, reflection over the x-axis.
Correct. Okay, reflection over the x-axis. Oh, you call it what? Okay, makes sense. Midline y equal to minus 1. Okay, Bhunesh, one another thing, Bhunesh. Midline, the equation should be there. It has to be an equation, Bhunesh. So y equal to minus 1, y equal to minus 2, y equal to 1. Do you see what I mean? Midline is a line, right?
Yeah.
So it has to be a line equation. See,
Okay.
I am nitpicky, honestly. Okay, that will dock points for you. So I'm telling that. Vibha, that's right. Huh? Amplitude. Nice. Ma'am, Vibha, is midline 1, Amma? Midline is an equation, guys. Equation of a line. Ritik.
Wait, I fixed my answer. Can you check it?
I'm a little worried. I don't know which answer. Yeah, 1 second, ma. 1 second, I'm checking.
Wait, Auntie, Do you mind if I show you on the screen? Because I like drew it. Or do you want me to type it out
Yeah,
in the chat?
you can show me on the screen. Absolutely, I'm fine. 1 minute, Amma, 1 minute, but I will
Okay.
give me 1 minute because I need to be very sure of the graph and then I can check, right? Hold on. 5/2 is 0, but this is,
Auntie,
yeah, Amma?
I just wanted to clarify, you wanted the midline, amplitude, reflection, and what else?
Okay, generally, okay. See, whenever you write down everything, you don't forget anything, right? So always I want you to write out the amplitude, midline. Those two are the first ones, max, min. Okay. Other than that, if you write out your period, it's so useful. Okay. And then phase shift. Okay. And then last here, there is a reflection. I would also want to write that. Then only I'll not forget when I do the graph. Got it?
Yes, thank you.
Okay. Now the problem here is, yeah, Ritik, I think that's correct. Midline y equal to 1 seems incorrect, ma Vibba. Check. Yeah, yeah, I think everything is correct. Okay, so are you able to draw the graph, all of you? Bhunesh, do you want to share the graph with you? So you know what? You can take a picture and send it to me as well in the chat. If that is easy. Whatever is easy, guys, for you. If you want to get it checked, you can send a picture as well, or you can show it on the video. Videos for younger kids, I'll feel.
Do you mind if I show it?
Sure, yeah, on the video, that's fine. I don't mind. Can you take it up? Yep, that seems okay. But the x-axis, I really want to know what you have got. Where is pi/2, pi?
Oh, okay. Yeah, I'll label it.
You see, without it, I cannot say whether you
Yeah,
got it.
yeah,
Okay?
yeah. Okay.
Auntie, can
Nitin,
you see my graph?
yeah, would be nice if you can share.
Can you see it? I'm holding it up.
Yeah, wait. Ritik. No, Ritik, it's your video is black.
Oh,
Getting to draw these is important, guys. Do you want me to share the graph or grid paper? Anything is okay, Nitin. Whatever is easy for you. Tejashvi as well. If you're showing it to me on the video, you have to let me know. Phase shift is pi/4. How, Naisha?
Isn't it C over B?
It is Seema, this you cannot write it as it is. Okay, so you have to take out the 2 as common. When you take the
Yeah.
2 as common, x minus pi/2, right? So the phase shift is this one, right?
Oh, I thought phase shift was C over B. I don't know why I have that written down. Let me change it then.
This is the phase shift. This is B. This is C.
Okay.
Oh, so you had. Wait, let me quickly check that. I have my own doubts. Phase shift is pi/2 to the right, correct? I know, Naisha. Where did you get that? Na?
Yeah,
Okay. I know where you got that from. I think it was my bad. You know what? I said don't use that then. I think I should have made it very clear. It was not your problem. It was my problem, I feel. Okay. Vertical shift of -1. Vertical shift of -1. Vertical shift of -1 now. Midline is minus. Okay. Okay, makes sense. Okay, guys. So you get the graph. Like to plot the graph. for you. Graph will end up like this. You can check the graph, what you have. Do you want the exact points or just the shape of the graph? I wanted to see what is the period and all. Meaning, where are you? Meaning, I want to see, right? Labeled X and Y axis, I want to see. Something like this, you see? Nitin. Do you see Nitin?
Yeah, I see it. I'm just confused how to draw it, that's all.
Oh, you're confused how to draw. So
Yeah, I don't know what I need to put on the graph.
okay, once I'll show you. Can one of you repeat the question for me? One of you repeat the question for me? What was the question I gave you guys? -2?
Oh,
-2 sine. It was parentheses. 2x. No, there was no like other
Yeah,
parentheses.
I'm
Yeah.
taking that as common. Is it okay?
Okay.
Then what is
And then it was -1.
okay. So this is what I would like you to show. Midline is midline moved down, you see? So y equal to -1 line is this. That is a midline. And then amplitude is 2. So 2 up and 2 down. See, the problem here is 2 up and 2 down, right? I feel like the graph is correct or incorrect. I need to see, guys. Okay, let's see. So the graph is actually 2 up and 2 down, right? 2 up means 2 up and 2 down. So this is 1 and this is -3. Now, actually, it has to pass, meaning here we will split it into pi by 2, pi, 3 pi by 2, 2 pi. We split it like this, right? One period I can show. However, see, that's why I need to write everything. Amplitude is 2, midline is y equal to -1. What else then? Midline, min max, we already graphed it. Min is -3, max is 1. Please, guys, that you need to make sure, don't exchange that. Okay. Now, phase shift is as well there. It's a pi by 2 to the right? See, that's where I have my own doubt. Okay. So here, basically, our graph would have been like this, right? It should go up to the maximum here. And then it'll go again here, 0. And then come down. It'll go to the -3 in here. And then it'll go to the 2 pi here, right? Should have been like this. This is the sine graph. However, I did not take the phase shift into account. Midline, I have taken it into account. And then what? Period is what now? Period also changed, right? Period changed to what? See, if I don't write it down, I'll make mistakes. Period is pi, right? So I have to take all that into account. I did not take period and the phase shift. So period is pi means here itself, it will attain one full cycle, right? This is another cycle. So basically, it should go up like this and pi by 2 should be 0. It should have been like this, right? It should have been like this. And then this is one. However, the phase shift should also be considered. So my actual graph is like this. Any questions, guys? Any questions? Any questions?
No.
The final graph should be like that. Can I move on? The black one, the black thickened one. Ritik, are we on board?
Yeah.
Let's go on. Okay, now, what did I want to do? Okay, so basically we are good with transformations. How about the tan x graph? Okay. I want to really go ahead with the tan and then cosecant secant, right? So tan, we can do one transformation now. or I can go to secant cosecant. Let's see. 3.8, 3.9. See, I want to come back to sinusoidal data modeling. Okay. So here, yep. Okay. Now, tan graph has a period of what? Last week, remember, we just started with the tan graph, right? Unit circle by hearting is very, very, very needed. By hearting the unit circle is very needed. Having said that, right? What is the period of the tan graph? Do you know?
Pi.
Pi. Yes. So now let's go ahead and try this one. Okay. Last week we drew the graph of tan graph and that's where we left off, remember? So how did we draw? Tan theta equal to sine by cos, right? If you have a unit circle, right? This is cos sine, right? Cos comma sine always. It's 1 comma 0, 0 comma minus 1, minus 1 comma 0, and then 0 comma 1, right? So now when you want to plot the tan graph, right? Let's go ahead with 0, pi by 2, pi. This we did it last week actually. This is where we left off. Now, when you look at a tan graph, right? Basically, it repeats cos by sine. See, cos by sine. So here the tan value is, I'm sorry, sine by cos, right? So the tan value is 0 here. At this point, right, tan pi. What is the value of tan pi? Cos by sine by cos, right? So what happens? Tan pi is what, guys?
An asymptote. Oh,
An
wait, not tan pi. That'd be 0. Wait, no.
No, right. Hold on. Now, wait. Am I making a mistake here? 1 comma 0 sine by cos. Sine by cos is 0. Tan 0 is something feels so wrong. Hold on. One second. One second. We are right. Yeah, we are right. I was a little off. Okay, so tan 0 is what, guys? Sine by cos, right? We are on the right track. 0 by 1. Tan 0 is 0, correct? Tan pi is 0, correct? So you see here, it repeats again. Do you see it? So 0. Do you see tan 0 is 0, tan pi is 0. So that being the case, what is tan pi by 2? Anybody? Cos sine, right? This is cos pi by 2.
Wouldn't
This,
tan pi by 2 be an asymptote?
yes, tan pi by 2 is sine pi by 2 by cos pi by 2. It becomes 1 by 0. So that is undefined. It is a vertical asymptote. Am I making sense? Similarly, minus pi by 2. Bhuvanesh, is it making sense?
Yeah.
Abhiram?
Yeah.
Okay. So now 0 comma 0. See here, tan 0 is a 0. So basically it passes through this point. And then these are asymptotes. So if you draw the graph, it's more like this. How do I get this graph? Before even I say that, right? The graph comes like this. I cannot say just like that, right? So let me go ahead with what is in between. Pi by 2, half of pi by 2 is pi by 4. Let me consider. Pi by 4 is here, right? For I made a mistake. Hold on. Okay. So pi by 4 is in between. Oh my God. 1 second, guys. I'm choosing the wrong pen. It is disappearing. Okay. Pi by 4, right? Pi by 4 is cos pi by 4, comma sine pi by 4 here, right? What is the value? See, guys, memorizing the unit circle is so important. Root 2 by 2, root 2 by 2. Okay. So now what is tan pi by 4, Bhuvanesh? Pi by 4 is midway. What is tan pi by 4?
Then pi by 4 is just 1.
1. So see, it goes to 1. Now similarly, tan minus pi by 4, that is halfway through this, right? Anti-clockwise, when you come, it's minus radians, right? So tan minus pi by 4 is this one. Here you have root 2 by 2, comma, minus root 2 by 2. That is cos minus pi by 4, sine minus pi by 4, right? So this one becomes for tan, then it becomes a minus 1. So here you go. So this will be the graph. So here the graph goes like this. Am I with you? Nitin, did you get it?
Yeah.
Okay. So unit circle memorizing is important. Also understand that this is a positive quadrant. This is a negative quadrant. This is a this is a negative quadrant. This is a positive negative quadrant. This is a negative positive quadrant. Are you all with me?
Yes.
Okay. So you have to remember where sine is positive, cos is positive, where's okay. Let's draw that. Sine is positive in which quadrant? Sine is positive here. Sine is positive here, positive here. Please remember, positive sign here. Cos, where is it positive? Cos is positive here and cos is positive in this quadrant. Did you all get it? You have to remember all these because you're going to memorize the unit circle slowly. Now, where is tan positive?
First quadrant and third quadrant.
Yeah, nice. First quadrant and third quadrant. You will have to remember this. The way I remember this is sine like this, cos like this, tan like this. You'll have to remember that. This comes only when you memorize. Okay, as we move on, you need to know in which quadrant, because when we try to discuss trigonometric inequalities and equations, right, which will be next class, we need to know where sine is positive, where even in the inverse trigonometric functions, which I'm going to discuss today, you might need it. Sine is positive in 2 quadrants, cos is positive in 2 quadrants, tan is positive in 2 quadrants. So you need to know which quadrants are they. Now we have drawn the tan graph, right? I would like to graph more transformations quickly. Let's see. Applications, I want to cover the applications. Let's see, first we'll do the transformations. How about, okay, I will do a tan transformation. Yeah, we'll do a tan, minus 3 tan x by 3. Minus 3 tan x by 3. Let's do that. Let's take this out. Can we try the transformed graph for this one? Let me draw it properly, guys. I would really like you to guide me rather than me guiding you. It's very similar, right? Minus 3 tan x by 3. Minus 3 tan x by 3. I want to see the graphs. Minus 3 tan x by 3. For this function, can we do the graph? First of all, amplitude. What is the amplitude here?
3.
Yeah, let's discuss. Okay, there is a reflection on x-axis and there is a horizontal. What is it?
Dilation.
What dilation means? Compression or stretch?
Compression. Or
Really?
stretch. Stretch by a factor of
Yeah,
3.
stretch by 3. Horizontal stretch by 3 means x value you'll have to multiply by 3 and then do. And so that's it, right? So let's find out. Our usual parent graph is how? Parent graph till minus pi by 2 I'll draw always because tan graph, right? The period is pi. So here let's see. The usual graph is like this. I'll put it in a dotted line. The usual graph that we just drew is like this, right? Then you have pi. That is your usual graph, but that's not what I want now. Okay. Let's try what happens. So we have written all of this in here. So basically there is no shift up or shift down, right? Okay, but there is a reflection on the x-axis. So what would happen to the graph? See, this is your x-axis, right? If it is reflected on this x-axis, what would happen to the graph? Who can describe? Go ahead.
As x approaches negative pi by 2, y will approach infinity. And then as it approaches pi by 2, it'll approach negative infinity.
Please repeat. Sorry, I did not listen. What was that?
As x approaches negative pi over 2, it'll go to infinity.
Nice. So it is a reflection, right? Think about this reflecting on the x-axis. It will become this. Think about this reflecting on the x-axis, and then the rest of it, please go ahead, Abhiram.
And
As
as it approaches pi by 2, it'll approach negative infinity.
Nice. So here the graph is said to be like this. However, wait, we have to plot the graph, meaning I cannot even draw these just that quick. So here, what happens? Amplitude is 3, correct? So for the amplitude to be 3, horizontal stretch by 3. So those needs to be accounted for, correct? So now what is the period first of all? Usually the period is pi, yeah. Usually the period is pi, but what happens here? B value is what? Okay, let's write it down, guys.
1/3.
Yeah, 1/3. Okay, let's see. Here, let's say amplitude is 3. Midline is usual, meaning we don't have a midline up or down. Okay, so y equal to 0. And now what else is there to say? Amplitude, midline. Let's talk about asymptotes. Asymptotes and then the period. That is quite important for us to draw the graph, right? Asymptote and periods. Asymptote we already found out, right? Asymptotes are at pi by 2 minus, let's first do it for one period, minus pi by 2, that moves on like that, right? So that's fine. Now, period, what is the period of this graph? See, here there is a problem, right? Period of the graph, then we can plot the asymptote. What is the period of this graph? Pi by b, right? Usually if it is sine and cos graphs, it's 2 pi by b. Here, for a transform graph, it's pi by b because tan graphs have a period of pi. So here, what is b? What is the value of b? What is the value of b?
1/3.
1/3. If b is 1/3, what will be the period?
3 pi.
3 pi. So everything shifts a little bit. Did you see that? The period is 3 pi. So what happens to the graph if the period is 3 pi? What is half of it? Let's redo the graph. So we just showed the reflection, but let's see. If it is 3 pi, the period is here. You get it? Am I making sense?
Yeah.
The period, one period should be shown within this. Okay, now let's try more. Period is 3 pi. So this is where, this is pi. Then which is 2 pi. Oh my God. This is 2 pi. This is 3 pi. Okay. So one period stretches across. Now what happens? Period is 3 pi. What else to say? Where are the asymptotes? Where are the asymptotes? See, in an original graph, if it was a tangent graph, let me draw this and show you. If it was an original graph, this was pi by 2, This is minus pi by 2, correct? Now, this was your graph. Am I making sense? For this, the period was pi. Now, we have a period of 3 pi. So, the thing about this is, and it has not undergone any left shift or right shift. As a result, if period is 3 pi, then you have to show 3 pi by 2 minus 3 pi by 2. Then only you can show the full period, right? So, let me go ahead and say this as, let me make the scale a little different. See, the period changes, everything changes for a tan graph. Let's see. I'll do this next one, I'll give it to you. So here, let's have this as the origin. Now, we'll go ahead with, what is this? This is 3 pi by 2. Let's go ahead with this. This is a minus 3 pi by 2. Okay, so that this is minus 3 pi. This is, that makes sense, 3 pi. Now, what I'm saying is the asymptotes are this and this because half of it, right? So, this period is 3 pi. Now, how do I plot this graph? I accounted for the period. But then at the point 3 pi by 4, right? This is minus 3 pi by 4. Remember, in our original graph at pi by 4 and minus pi by 4, right? The value was 1. I plotted and showed you value was minus 1 and minus 1 and 1. Remember, at minus pi by 4, it was minus 1. Plus pi by 4, it was 1. Here, the amplitude is 3. So, basically, this is 3. Here, it is minus 3. Now the graph goes like this. There is a reflection as well. Oh my gosh. So what happens? This comes here, this goes up, then the graph goes like this. Am I making sense, guys? So the only thing is you'll have to take into account everything. Unless you write down everything, you're going to miss one or two. The graph is right though. Make sense? You have to take into account period. When performing the transformation, it is quite important. Okay, shall we try cot x minus, okay, I did not teach cot graph for this. Oh my gosh, okay. Okay, let's try. Now, here guys, how will you write out the asymptotes? I also want to discuss that. How will we write the asymptotes? In this graph, if you're asked to write what are the asymptotes, right? I know for one period, it's very easy to write the asymptotes. Asymptotes are 3 pi by 2, meaning from 0 to 3 pi by 2 minus 3 pi by 2, like that. But then, where are the asymptotes? The period is 3 pi. So, how can I write that? Anybody? See, first, from 0, what is the first asymptote is at 3 pi by 2, correct? So, 3 pi by 2 plus what is the period of this graph? 3 pi. So, the asymptote repeats after any integer multiple of 3 pi. Am I making sense? Bhuvanesh, Nitin, Abhiram?
Yeah.
Yeah.
So here, why are we calling these as, see, for one period, it's very easy to say the asymptote. The period is 3 pi. Okay. See, the period is pi, right? Usually in a parent tan graph, the period is pi. So the asymptotes occur at pi by 2 minus pi by 2. Okay. Making the period as pi. This is the usual tan graph. However, here what happened? The period switched to 3 pi. This is a confusing point. The period switched to 3 pi. When the period switched to 3 pi, half of it you had the asymptote, which is correct. The first asymptote was at 3 pi by 2. But how will you write when all the, meaning what are the occurrences of all asymptote? So 3 pi by 2, 3 pi by 2, and then the asymptote repeats for every period, right? For every period, the same asymptote repeats. So plus 3 pi, but an integer multiple, it can be 1, 2, 3. So for every integer multiple, there is always an asymptote. So this period is always 3 pi. How will you write that into an equation? The first asymptote plus the period times k. Am I making sense? Naisha, am I making sense?
Yeah, I think so. I'm just trying to.
Not much, okay. Ritik, how about you? No, I want you to understand. Wait.
Yeah, I understand.
Okay,
Sorry.
where am I? Okay. Ritik, I got that you got it. Bhuvnesh, am I making sense?
Yes.
Okay, how about Naisha? Where is that you don't understand? Tell me.
No, I think in theory I understand. I just need to see more like.
Okay, more problems?
Yeah.
More problems, then you should all do the homework as well. Then only some more doubts will come. Okay, let's see. Let me go ahead and do more transformations, particularly tan when the period changes. That's why I took this first. But let me see. Give me a minute. I'll give you more. I really want to do cosecant secant graphs. How about this, guys? Can I get -3 cos x -2? Can we plot that? I'll go to another tan. Okay. -3 cos x -2. Vibha, are you with me?
Yeah, auntie.
How about this? Can we plot this graph? Let me try. What is going on? The more I want to draw a straight line, the more it's crooked. Okay, this time can I ask one of you to draw rather than me drawing on the board? So that way we are very... -3 cos x -2. Please write down all our data. Bhuvanesh or Nitin, do you want to help me this time?
Can I do it first and then can I tell you everything?
Sure. Amplitude, max, min. Please don't write, forget to write anything. Otherwise, we are going to miss very badly. Reflection is there on x-axis. And then period, I want to calculate. Period is basically 2 pi, right? Nothing is being done to it. Yeah, because b value is 1. So it's an easy graph. So pi by 2, pi, 3 pi by 2, 2 pi. Nidhi, are you on board with me?
Yeah.
In the meantime, I really want to find out one problem on tan transformation, which was a little difficult, right? Let me find it out. Please, guys, go ahead and do this one. Then we'll discuss the other graphs as well. I want a tan transformation of the graph. I don't know. I didn't. Let's see. Yeah, why don't we do this one? Yeah, this one is good one. Let's see. This is a hard one. Let's see. I really want to do this one.
Auntie, is it okay if I go to the restroom?
Yeah, please.
Okay, thank you.
See, another thing which I missed to tell you is to write the domain and range for every transformed graph. We will do that here. What did I give you? -3. Okay, let's do that. See, if you do more homework, then you'll have more questions. You can come back to class and ask, I feel. Yeah, we are going to draw. Okay, we are going to write out everything. In addition, what did I miss to ask you to do? I want you to write out the domain range of the transformed graph. Let's try, guys. Shall I do it on the board or you want to do? Please, I really want it to be interactive. Go ahead and tell me.
Is my graph right?
Go ahead. Oh wow. Okay, wait. I want to see. 1 minute, ma. 1 minute, ma. Wait, ma. 1 minute, ma. Please give me a minute. Is your graph right? What is that midline line? Can you tell me what is that midline line?
It's 2. I just made a dotted line so I could know where to draw it.
It's 2 or -2?
Isn't it 2 because it's a reflection?
Okay. Show me your graph. Midline is 2. Oh, you took it up. That is incorrect, ma.
Oh wait, I think I did.
What is I got where you got confused. Ritik, what is the min value, max value? Or Bhuvanesh, can you tell me the min value, max value? Or Nitin, can you tell me the min value, max value?
I have maximum 1.
What is it?
Maximum would be 1.
Correct. Maximum would be 1. See, the amplitude here is what? 3. Midline is?
Y equal -2.
Yeah. So the maximum is 1. Minimum is? -5. There is a reflection on the x-axis. Period continues to be 2 pi. So do you see what is the domain of the graph? Domain is very easy. -infinity to infinity. But what is the range of the graph? What is the range of the graph? -5 to 1, guys. Square brackets. Why? Because the graph sinusoidally goes up and down between -5 and -1. So I have -5. Bhuvanesh, can you plot and show me?
I don't know how to
You don't know how to?
plot it on the Zoom.
No problem. You can plot it on the paper and show it to me.
Okay.
So now midline is y equal to -2. Vibha, did you get the graph now correctly?
Yeah.
Okay. So there is a reflection. So what happens? Actually, it should be at 0, but there is a 0, and then pi again, it will be a 0 with an up, right? Vibha, did you take into account the reflection?
Yeah, wouldn't it be from the bottom?
Yeah, it would be from the bottom. So at pi by 2, it will go to a 5. -5. You see what I mean? So 1 is maximum, right? So it will go like this. Am I making sense? Then go here. Make sense? Does it make sense, guys? There's no asymptotes here, so I don't need to write that down.
Wouldn't it not be like that because it's this cosine graph and not a sine graph?
Oh my gosh. I'm sorry. A cosine graph. I drew it for a sine. Good catch, Vibha. So this should have been a 1, right? Okay, wait. Then things will change. Okay, come here. I was drawing for a sine graph. I did not see. So here, let's draw this. Line is at -2, so this is a 0. Okay, now this is my maximum. Which is my maximum? 1 is my maximum. Which is my minimum? -5. Okay, so I have this. So now my usual cos graph would have been like this. The maximum here, and then again maximum comes at here, minimum is here, and then it crosses 0 point here, and then it crosses 0 point here. It crosses 0 point here, Maximum comes again here. However, is there any phase shift? None, but there is a reflection. So what happens? So this is my final point. This is my final point. This is my final point. Is that making sense, guys? Make sense? Vibha, is it okay?
Yeah.
Okay. So this will be our graph. I would like you to do these for one or two at least. Can I move on? Let's try this one. I said I'll give you a tan graph, right? Tan graph. Okay, how about this? Let's try to plot tan x plus pi by 4. Tan x plus pi by 4. It's a little tricky. Tan x plus pi by 4. Tan x plus pi by 4. It's a little tricky, honestly, I'll tell you, because see, tan graphs with the tan x plus pi by 4. Let's see. Can we try one by one? I don't need to do amplitude here, but yeah, it's 1 and then what? Guys, go ahead and tell me. There's a phase shift of pi by 4
Pi
to
by 4 to the left.
left. But the thing is, mainly this transform tan graph, you have to find the period. What is the period? Usual
Pi.
period is pi. Usual period is pi, correct. Here it continues to be pi. Great. Okay, let's try the graph. Bhuvanesh, can I ask for your help to draw the graph, or Nitin, can I ask your help to draw the graph?
Can I help?
Yeah, please. I really like you volunteering. Go ahead.
So there will be an asymptote at negative.
Nice. Asymptote we
3.
need to write. Yes.
Yeah. There'd
Where
be
we,
there'd be an asymptote negative 3 pi over 4.
nice.
And there'd be another asymptote at pi over 4.
Very nice. So the first asymptote, see here, the problem is our usual graph is pi only. The period is pi, but then the asymptotes are at pi by 2. So here the problem is it's phase shifted pi by 2. So our usual graph, let me draw as first like this. Minus pi by 2, this is pi by 2. So the usual graph would have been like this. It's only amplitude 1, so that continues. Go ahead, Ritik. So
Yeah,
now,
then there would be
so there is a
after the asymptotes at the point at the x equals 0, the y value would be 1
nice. Why?
because we shifted everything to the left.
That's true. Good
Yeah.
job. So we shifted at pi by 4, it was 1. So it was shifted to the left. So that this one marking, right, goes to the left. And the asymptote, which was here, moved pi by 4 to the left. So our graph should go like this. But to the left, what happens? We need to find out. Here you have a minus pi by 2. Here you have a minus pi by 4. And what happens to the left? Minus pi by 4, minus pi by 2, and then minus 3 pi by 4. So where do I draw the asymptote? I drew the asymptote at minus pi by 4, but my period is pi. So where should I draw the next asymptote? Can I call a name? Bhuvanesh or Nitin, can you tell me where should I draw the next asymptote?
Maybe 3 pi over 2.
3 pi by?
Over 2.
Good job. 3 pi by 2. Nice. Because the period is pi. So it is 3 pi by 2, 3 pi by see, from pi minus pi by 4 I need to add this is plus pi by 4, I'm sorry, plus pi by 4. I need to go back, right, meaning I need to subtract a pi. So what happens there? Minus 3 pi by 4. What am I?
Made so many changes to my answer.
Okay, good. Now I don't have it. So minus 3 pi by 4. So this is minus pi. Make sense, huh? How I am plotting? Plus pi by 4 is the first asymptote. Then you need to subtract minus pi so that you know which is your next asymptote. So it is minus 3 pi by 4. So my graph goes where? So between this, it reaches 0 and then goes straight here. Am I making sense?
Yeah.
Okay, now please let's write the domain and range. It's very important for transform tan graphs. It's a little tricky too. What is the domain and range?
X can't equal
Yeah.
X can't equal to pi pi minus pi plus pi over 4x. Wait, no. Minus pi over minus 3 pi over 4 plus pi x.
Plus pi x.
Pi k.
Okay. Okay. But can I just make a change in this?
Yeah.
Can't we write pi by 4 plus pi k?
Oh yeah, you can.
Easy,
Yeah.
right? The first
Yeah.
asymptote plus pi k is easier than stating this. See, I'm not denying. Both are one and the same. See what I mean?
Yeah.
It's easy to write the first asymptote after 0 and then plus pi k. Why is it pi k, Nitin? First, I have to write what are the asymptotes. Asymptotes are x equal to first asymptote pi by 4 plus pi k. Now, the domain is x not equal to pi by 4 plus pi k. Because at those points, we have asymptotes. Range is easy. Minus infinity to infinity. Range of a tan graph is easy whatsoever. Am I on board with all of you?
Yeah.
Okay. I did not do applications. I know applications are quite easier than other stuff, I feel, but I want to do the other graphs now. Let me see which graphs I want to do. Yeah, I want to do the cot, secant, and the inverse graphs. Hold on a minute. 3.11. Yep. I really want to go over those graphs. Okay. Now, here, cosecant theta will be equal to 1 by sine theta. These are not inverses. There are trigonometric inverse functions. Trigonometric inverse functions should not be confused with this reciprocal functions. These are called reciprocal functions in trigonometry. Reciprocal functions are different from inverse trig functions. So secant theta, this is cot theta will be equal to 1 by tan theta. Can I move on? Can I move on?
Yeah.
Now, how do you find out cosecant pi by 6? How do you find out cosecant pi by 6? Cosecant pi by 6 is basically 1 by sine pi by 6. Immediately unit circle should come up for you. Sine pi by 6 is 1 by 2. So the cosecant pi by 6 is 2. Make sense? Okay, what is cot 4 pi by 3? You are going to do, guys. What is cot 4 pi by 3? Use the unit circle, but you have to memorize it. Cot 4 pi by 3. Can I help you? Nidhi, you're on board, Amma.
Yeah.
Okay. What is it, guys? What is cot 4 pi by 3? What is cot 4 pi by 3? Or this can also be cos theta by sin theta, right? So cos 4 pi by 3 divided by... Gunesh, did you get the answer?
I'm doing.
Yashita, are you getting the answer?
Yeah.
Did you get it?
Mm-hmm.
Okay, what is the answer? I'm
No,
not getting...
I'm still working on this one.
Naisha, there is a big thing here. Your denominator can never be irrational. That's why I picked this value. Your denominator can never be irrational. So you have to rationalize your denominator and tell me the answer.
Okay.
So instead of saying 1 by root 3, you should multiply root 3 in the numerator and denominator. That gets you to root 3 by 3 as the answer. Shall I move on? Okay. Shall I move on?
Yes.
For the cosecant graph, I'll just get the help of this graph. See, let me go ahead. So answer was root 3 by 3. I'm going to plot cosecant x. How do you plot cosecant x? We know pi, 2 pi. The period was 2 pi for a sine graph, right? So the sine graph was like this. Any questions on the sine graph? No questions, right? So this is easy. So this was 1, this was minus 1. Now, cosecant x is 1 by sine x. Okay. Now what happened, you see? Sine 0. I'm going to plot it into a table literally for quick reference, okay? So I'm going to plot theta in radians, sine theta, then I'm going to plot cosecant theta, okay? So for you to be quick, it's easy. Now, theta in radians 0, then what happened? Pi by 2 was 1. Then pi, sine pi by 2. Sine pi by 2 was 1. So 1 by 1 is a 1. You see, this remains the same. But the problem with this is sine 0 is a 0. So cosecant is undefined. Now pi. What happened to pi? Again, 0. So here it is undefined. Abhiram, can you help me with the next one? 3 pi by 2 and 2 pi. What is 3 pi by 2? Guys, what is 3 pi by 2? Sine 3 pi by 2. 3 pi by 2.
Would it be -1?
-1. So cosecant will be -1. 2 pi, sine 2 pi is a 0. So this will be undefined. See how many undefined. So now it starts at undefined, goes to a value of 1. See, so at 0, it is already undefined. It's coming from somewhere up. It is already undefined. But then at pi by 2, it goes to 1. So it is the same as a sine graph. At its peak, it remains the same. But otherwise, again, what happens? At pi, it goes to undefined. You see what happens? Guys, are you with me?
Yeah.
The cosecant graphs, if you plot the sine graphs, then cosecant graphs are easy. If you plot the cos graphs, then the secant graphs are easy. So this is the parent cosecant graph. Coming to secant graphs, right? Again, Bhuvanesh, for this one, can you help me?
Okay.
I want to do it like this. I'm sorry. because I don't have space. So pi by 2 pi, 3 pi by 2, 2 pi. Go ahead, Bunesh. So this is going to be 1 by cos x, right? So let me draw in radians, theta in radians, cos theta, secant theta. So go ahead. I should have written theta. Go ahead. Now 0, pi by 2, pi, 3 pi by 2, 2 pi. Go ahead. Cos 0 is what? Okay, let me draw for you. Cos 0 is what? It's going to be like this, right, Bunesh?
Yeah.
Okay, now go ahead. Cos 0 is what? Cos 0,
1.
1. So secant 0, just plug it in. 1 by 1 is 1. Cos pi by 2 is
0.
0. So secant 0 is 1
Just
by 0. 1 by 0 is not defined, right? So it will be undefined. It will go up or down. Pi is cos pi is what? -1. Secant theta is what? Secant pi is
-1.
-1, correct. 3 pi by 2, 0. Secant theta is undefined. 2 pi maximum, right? So 1, again it is 1. Can we go ahead and draw this one? So this one when you draw, right? So what happens here? This one, how do we draw? 1 for 0, it is 1. Pi by 2, it's undefined. Okay, so my asymptotes are differing here. You see, pi by 2. So here, what happens here? So 0, it is a 1. It is there. But from 1, it moves to undefined. Then the next one, at pi, it is a -1. I have this graph. Whereas for 3 pi by 2, it goes to undefined. See what happens. So the graph went to undefined. So I'll have to bring it again from here. And then at 3 pi by 2, it goes to undefined. Do you see? 3 pi by 2 goes to undefined. Then at 2 pi, it's again at a 1. So since it went to undefined, I have to bring it up from here, then go here. Am I with you all?
Yeah, I understand.
The same with cot. What happened? Cot x will be equal to 1 by tan x. You know the graph. This is a reciprocal function. So again, we'll have the graph was like this, remember? This was, the period was like this. It went like this, right? So this was the origin. This was minus pi by 2. This is pi by 2. So it went like that. So the period was pi for a tan graph, right? But it is 1 by tan graph. That means what happens? So wherever there is a 1, it will be an asymptote. Wherever there is an asymptote, it will go through 0. So let's see. Let's see how a chord graph is done. Let's go ahead and try a chord graph. The period is anyway going to be, what will be the period of a chord graph, Bhuvanesh? What will be the period of a chord graph?
After
What is it, ma?
I,
Period of a chord.
yeah, I know that.
What is it?
pi.
Pi only, yeah. Tan x, this is cot x. Okay, now x in radians 0, pi by 2, 0. I will go ahead with pi by 2 maybe, yeah. Pi by 2, then what did we do? Pi, we don't need to do so much because it's only the period is pi, right? So let's go ahead with only one period, 0, pi by 2 and pi. Now what happens? Tan 0 is what? Tan 0 is a 0. So it starts at undefined. Now, tan pi by 2 was undefined. Basically, this is cos x by sin x, right? Now, cos pi by 2 was a 0. Sin pi by 2 is what? Sin pi by 2 is a 1, right? So what happens here at pi by 2? What happens? It becomes a 0. 0 by 1 is a 0. Now, come to tan pi. Tan pi was what? Tan pi was 0. So this goes to undefined. Now, let's draw only one period I said, right? So 0 to pi. Now what happens at 0? 0 has undefined. Pi by 2 has a 0. Pi by 2 is a 0. 0 was undefined. Do you see from here? It goes till here. Pi by 2 is again undefined. The thing is, how can you plot the intermediate points? Do it for pi by 4 and see. Pi by 4 is cos pi by 4 divided by sin pi by 4, right? So that will be 1. Now, again you can do for 3 pi, you can do for 3, you can do for what? 3 pi by 2. When you do for 3 pi by 2, again it will be a minus 1. So basically, in between this will be a minus 1. Here, right smack in the middle will be a 1. So these three are the points. Chord graph will be a graph that goes from up to down, from 0 to pi, and the period will be pi. Any questions? Any questions? Any questions, guys?
No, I have no questions.
Okay. 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 So can we stop here? See, transformations will be easy for cot, secant, and cosecant function only if you plot the sine, cos, tan curves. First plot them as sine, cos, tan curves and then make it into secant graphs. Then it becomes very easy if it is cos. If it is sine, cosecant, meaning if you are given to draw a cosecant graph, draw the dot sine graph, then you will get it easily. Okay, I'll stop here, but I'll continue next week. What I did not do is the applications, which I'll do it next week. Applications, sinusoidal modeling, transformation of secant, cosecant, I have not covered. Any questions? Anytime you can ping me. Okay, I'll help you with the answers. Okay, guys. Let me know if you have any questions.
Thank you, Auntie. Bye.
Thank you. Bye.
Bye.
Bye, Auntie.
Bye, ma. Yeah, Shita. You're following, Amma?